Welcome back to the Deep Dive. Today we're charting a really massive and almost silent shift in how we build our world.
It's a big one.
We're diving into your sources on what's being called vibe coding. Specifically, that huge inflection point around 2026 that just changed software engineering forever.
Fundamentally.
So our mission today is to figure out how the barrier to building these incredibly complex digital tools basically hit zero. And more importantly, what that convenience actually cost us.
The builders, yeah. The people who made the tools in the first place.
To really get it, you have to think back just a few years. I mean, before 2026, if you wanted to talk to a computer, you were basically subservient to it.
Oh, completely. You had to learn its language.
All right. You had to memorize all the rules for C, Python, Java, you name it. You were this highly paid, very meticulous translator between human ideas and cold, hard silicon.
And that translation was brutal. The sources are pretty clear on that. The machine gave you nothing. It never met you halfway.
Not at all.
It was a constant fight. Syntax errors, hours spent chasing a missing semicolon, a fatal compiler error with zero helpful information.
It was punishing.
Yeah.
It was designed to weed people out.
And what's so wild is how fast that wall just collapsed. Your sources all point to that 2026 timeframe, where suddenly the gap between thinking something and doing it just vanished.
Gone. Builders stopped explaining how to do something. They just started stating what they wanted done.
Yeah, and the example from the research is perfect. Build me a budget tracker that looks like a Game Boy, syncs with my bank, and scales to 1 million users.
A task that used to be a senior engineer's entire quarter, maybe a whole team's. Now, the modern agent just understands that descriptive intent instantly.
No syntax fights.
No stack traces, just
Sure.
poof, an entire architecture scaffolded.
Which is why the analysis we're looking at says we are now definitively in the era of vibe coding. The most powerful programming language isn't C++ anymore, it's just English. And the big implication there is that the most important skill isn't logic, it's that. It's taste. Which brings us to the central question, the one you sent over. If a machine can do the work of 1,000 developers, what happens to the value of the developer? Does it just go to zero?
That's the tension, right? The machine is a perfect laborer, but it has no judgment.
No inherent taste.
Okay, so let's unpack this. Phase one, what even is vibe coding? It started out, I think, as a joke on Twitter, right? I mean,
It was a punchline
yeah.
about lazy developers, and now it's just the default. It's how modern software is built. You're describing intent, not implementation.
The outcome, not the steps.
Exactly. And it's a loop. It's not a one-shot prompt. You're in a conversation with the tool, refining things.
Using like non-technical language.
Totally. Things like, make this data viz pop more, or my favorite one from the sources, make the UI feel more aggressive.
What does that even mean? But the machine gets it. You're refining the feel, the vibe, not the underlying code.
That distinction is everything. Feel versus logic.
And the sources break the workflow into 3 parts. First, intent. You define the outcome. Second, iteration. You refine that vibe. But the third part, the agent, that's the real game changer.
Yes. The agent is what makes this different from, say, just better autocomplete. This isn't a suggestion tool, it's an execution engine.
It's doing major engineering work automatically.
Critical infrastructure duties, yeah.
Okay, can we ground that a little? What does it mean that it handles deployment for someone actually using this?
It means you, the user, never open a command line. You never configure a deployment pipeline. The agent writes the app, puts it in a Docker container, spins up the servers in the cloud, manages the networking, the security.
That it handles dependency hell.
All of it on its own. It's a self-contained unit of work from a simple description. It even debugs itself as it goes.
So the old way was being a perfect typist. Yeah. Now you're not writing a script, you're conducting an orchestra.
That's the analogy from the sources, and it's perfect. The machine plays all the instruments at light speed. Your only job is to say, that doesn't sound right, and describe a mood change.
It's a massive shift in responsibility, which leads us right into phase 2, the frictionless trap.
And we have to be fair, the appeal here is immense. This is real progress.
Oh, for sure.
A designer builds a whole sauce product in an afternoon. A biologist writes a complex simulation without a CS degree. This solves so many problems.
It does. But the sources are all very clear. This comes with a huge catch. The frictionless trap. The old wisdom was that the friction, the struggle, that was the teacher.
Think about spending 6 hours hunting a memory leak.
Yeah.
That pain, that agonizing effort, it taught you how the machine breathed, it taught you its limits, its weaknesses. You had to learn the metal.
But vibe coding just smooths all of that away. And that's where the problem comes in. When you vibe your way into a solution, you're building this giant complex thing on a foundation you just don't understand at all.
Exactly. There's that one quote that's just devastating. We're creating a generation of architects who have never laid a brick.
And if you've never felt the weight of a brick, you don't know where the weak spots are.
You don't know what's actually hard.
I have to push back a little here, though. Are we just romanticizing the struggle? I mean, does pain really teach understanding? Or does it just cause burnout and keep people out of the field? Isn't the point of technology to abstract away the painful parts?
That's a fair challenge. It's the core debate right now. The argument in the research isn't that the old friction was good. It's that it was necessary for a certain kind of insight.
Okay.
If you've never laid a brick, you might design a beautiful wall that's structurally impossible. You won't know that the AI chose a database that's going to cost $1 million a month when you scale up. You don't feel that future pain.
So the lack of friction hides the architectural debt. And from a risk perspective, if the agent hallucinates a subtle security flaw deep in the code,
Do you even have the eyes to see it?
if you never learned what an SQL injection attack looked like, how would you ever spot a new version of it?
Right. Or if the system just fails silently, where do you even start looking? You got the win without the fight, and the fight was where you forged that deep instinctual understanding. We're trading that instinct for speed.
Which sets up phase 3 perfectly. The new currency. Technical taste. If anyone can code, who wins? The sources are blunt about this. Around 2026, the average developer effectively became a commodity.
Their core function, writing routine code, was automated. And what replaces them isn't necessarily another coder, it's a product visionary, someone with technical taste.
And this taste thing, it's hard to define, right? It's not a metric you can put on a resume.
No, but you know it when you see it. It's immediately recognizable in the final product. That's the new essential role.
Okay, let's make it concrete.
Yeah.
What does technical taste actually look like in this new vibe environment, beyond just a good feel?
It's looking at an interface the AI generated and knowing instantly that while it works, it has some deep architectural flaw that will cause problems in 2 years.
It's anticipating things beyond the happy path.
Yes, it's knowing which weird edge cases are going to actually hurt real users, like someone with a really long name signing up on a tiny phone screen. The AI won't see that as a critical bug, but a person with taste knows that's a point of frustration.
So it's moving from does this function to is this elegant? Is this maintainable? Is this efficient?
Exactly. It's knowing when something is, quote, technically correct, but spiritually wrong. That just nails it. We've moved from an era of syntax and execution to an era of curation and judgment.
Your value isn't in your fingers anymore.
Yeah.
It's in your brain, exercising better judgment. The machine builds anything, but the human defines what should exist.
And how it should behave over the long term, yeah.
That distinction leads us right into the dark side of this. Phase 4, the 2026 engineering crisis.
This is where it gets serious. The problem is scale. The sources call it the black box. We are deploying billions, soon to be trillions, of lines of code that no human has ever read.
We're creating black box infrastructure, systems the entire global economy runs on, but nobody actually understands how they work under the hood.
And that creates a massive immediate audit problem, especially in, say, finance.
Right. The sources flag that as a huge concern. If a trading algorithm starts discriminating based on some weird pattern it learned from the training data, how do you audit a vibe?
You can't. You can see the prompt that was given and the final output, but there's no line of code, no log file that says, here's the biased decision I made and why.
So how do regulators assign accountability? How do you fix the root cause of a systemic flaw if the logic is totally opaque?
You can't. And that leads to the biggest long-term risk, the comprehension trade-off. It's about generational knowledge.
We're automating away the work of junior engineers.
But we're also automating away their only path to becoming senior engineers. The current senior cohort, the people who actually understand the metal, how an operating system works, how compilers work, they're all going to retire in the next 10 years.
We're staring at a knowledge cliff.
It's worse than a cliff. It's like we're building self-driving cars but forgetting how to make tires. When the machine breaks in a really new, catastrophic way, a bug in a core library, a new kind of security flaw, who's left that can actually diagnose it at that low level?
You've traded convenience for comprehension before, but never this fast.
Never at this scale. We automated understanding itself, and the sources all agree. Once that knowledge is lost from the human workforce, it is incredibly difficult, maybe impossible, to get back.
So what does this all mean for you listening to this, someone who's building in this new world? We've laid out the conflict. Incredible convenience versus this fundamental loss of knowledge. The sources do offer a strategy for survival.
Yeah, and the advice is very pragmatic. Don't reject the tools. That's just career suicide. But don't surrender your curiosity to them.
Use the AI for the boring stuff.
Let it handle the boilerplate, the routine code, the deployments. Treat it like a superpowered intern.
But the key is what you do with all the time you just saved. That's where you have to reclaim that lost understanding.
Spend those saved hours going deep on the hard parts the AI hid from you. Learn how the database actually works, down to the query execution plan. Understand the math behind the encryption it chose. Study the network architecture.
Be curious about the why behind the architecture, not just the what of the feature.
Be the hybrid. That's the goal.
The person who can vibe the vision with incredible taste, but can also step in and do the surgery when the lights go out. That mix of high-level judgment and low-level knowledge, that's the rarest and most valuable thing now.
Because in a world where everyone can talk to the machine, the only people who really matter are the ones who know what to say when the machine is wrong.
And who know how to check its work. So the final takeaway here, the advice from all this research, isn't just to prompt for an answer. It's to spend your time thinking about why that answer worked, what choices the agent made, and what happens when its assumptions fail.
That's what separates the builder from the engineer.
Don't just prompt.